So, guys, we will now jump into the second part of this session, and we will talk about privatized deep space exploration. I'm joined by Matthias. Matthias Pott, please join me here. Thank you. So, guys, Matthias, I shortly talked a bit about his background in the start. He is one of Europe's first new space entrepreneurs. After almost 20 years in traditional aerospace, defense, and security industry, he disrupted himself, and in 2014, he went to Silicon Valley to learn more about the upcoming new space movement. And as a result, he founded several new space companies to implement a European mega constellation for satellite-based industrial broadband connectivity solutions. Currently, he is establishing, among others, Polaris Space Ventures as an investment platform to engage in early-stage new space startups and leverage his expertise to support founders. This makes me very happy because I am a founder. So, just recently, he founded Leoconomy Holding to establish an ecosystem to bring space and non-space industries together and build a space-as-a-service company. Matthias is driven by his broader vision to develop new economic perspectives by leveraging deep tech to master societal challenges. So yeah, Matthias, thank you so much for joining us. A very cool thing that happened quite in recent years, I think it was the UAE mission to Mars and having the first weather monitoring satellite on Mars. What have been some of the cool kind of deep space private missions you have seen over the past years?
Well, first of all, thank you very much for having me on this panel. A little bit on short notice, right? Yeah. So I'm very happy to be here and talk to you and speak with you in the audience. And I mean, deep space exploration is, of course, getting more and more attention in the private sector as well. But I think it's still not the main focus, I would say, because if it's driven by private companies, it's very much driven by private money, of course. And the returns for deep space exploration missions is, of course, far, far in the future. So what I observe, and which is also my main focus, is on low Earth orbit and lunar, because this is where we see commercial business coming up, and we can deep dive a little bit on this. However, of course, we do see the Mars getting more and more into the focus, namely driven by Elon Musk and now Donald Trump. I mean, I don't know who has listened to the inauguration speech. I mean, he mentioned space as one of the top priorities, and he mentioned explicitly Mars, and there was this little video showing how happy Elon was about that. And I mean, he's driven by that. And of course, around that, you see companies coming up. But from a pure investment point of view, I would challenge, you know, how this really comes. And a personal opinion on that as well. I think let's make use of space as a mean to make planet Earth a better place and help planet Earth mastering challenges, because terraforming Mars is probably more ambitious than even today still try to change the climate on planet Earth.
Yeah, I totally agree. There's this misconception from some people that the goal of space is to leave Earth, but this was never the goal, and this is not the goal of Musk or Bezos or any of these other high capital individuals engaging in the space industry. Earth is paradise, right? We are the human race is like a cookie cut out from a cookie cutter, perfectly fitting, and the cookie cutter is planet Earth. But yeah, I agree about this. I mean, what's the ROI of colonizing and terraforming Mars? It's like so far in the future. But there are kind of two opposing philosophies in going out there and colonizing other planets. It's the direct to Mars way, which is what Musk is proposing. This is just you travel from Earth and kind of directly to Mars. You send up the rockets, you leave them for a bit in low Earth orbit, you refill them, and then you send them to Mars. And the opposing philosophy, it's what NASA is actually laying out for the coming tens of years. It is to use the moon as a gas station. And here we have lots of business opportunities, actually. NASA have put up several fully privatized missions to the moon. Last year we saw a great deal of them. Some, I would say, great success, varying degrees of kind of mission completion. But yeah, what are some of the interesting business opportunities you see on the lunar economy?
Well, I mean, first of all, getting there and returning. I mean, it's not easy. I mean, even if we mastered already like 55 years ago with Apollo 11, and we have seen private missions being successful, we have also seen other private missions not being successful. So landing on moon is still something. So you have to travel there, you have to land. Once you're on planet moon, you really then need to move around. So you need rovers that can move and basically exploit moon and understand it much better. And then, of course, finding raw materials and start building infrastructures there, habitats, facilities. But this also takes some time. But this is the interesting part. Basically, we have to build the same kind of infrastructure we all know on Earth. It's communication. It is moving people around, supplying people, make them travel there, back and forth. So it's an entire ecosystem. This is going to be established there going forward. And the reason why is indeed NASA wants to use moon as a springboard for deep space exploration, because it's much easier to start from there rather than from Earth, because what makes space still very expensive are the first, let's say, 10 kilometers to overcome gravity. Once you're out there, it's much easier. And if you have the fuel there, it's also just nice to start from there.
Yeah, I agree. Of course, I support the kind of Musk's notion of let's just do it, let's just go directly to Mars. But I mean, Earth is a gravitational well, and Moon is such a better place to have as a permanent base. And I'm truly happy about the ambitions plans laid out by the United States government and by the Artemis program as a whole.
But if I just jump in there, it will be interesting to see now. I mean, we all know that Elon is personally driven by going to Mars. We know that probably the new administration is not so much in taking care of conflicts of interest, and now with Musk also being the Department of Government Efficiency, and they skipped basically Moon. Side note, I mean, SpaceX, as part of the Artemis program, is responsible for the human lander system based on Starship. They are facing delays. So maybe skipping Moon because it's not of interest and going straight to Mars could be also kind of distraction from their own challenges. So we will have to see what is going to happen to Artemis, to be honest. I don't know. Hopefully it stays, because for me this is also a great example for international collaboration, which we all hope will continue. But let's see what the Department of Government Efficiency, SpaceX, and the president is going to do.
Yeah, I mean, many things have been said about the Artemis program. The SLS, it's kind of over budget. It's $2 billion US pop right now. It's become kind of a laughingstock in the space industry, but we must not forget that we need actually government actors in the space industry. Everything is actually driven by government actors, and we can't have a purely ROI-based privatized ecosystem actually, because some things are too important actually, and in my opinion, colonizing Moon, colonizing Mars, Venus, the outer moons, this is kind of it's a superhuman goal, right? It's for all of humanity, and it's just too important to not have some kind of strict government actors going in and saying that we are going to the moon or we are going to Mars. But I want to talk a bit more about the moon. So the kind of power of having a kind of a gas station on the moon, it's that obviously the gravitational well, it's much easier to launch. The escape velocity on the moon, it's so much lower than on Earth. You don't have an atmosphere you have to fight against when you travel off the planetary body. But also the moon has ice. It has H2O ice. And why is this good? Many people are surprised when they hear that H2O is actually the second most abundant molecule in the universe. Well, ice can be used for several things. The most efficient rockets in the world, they actually run on hydrogen and oxygen. All rockets are mainly composed of an oxidizer and then a bit of fuel. So if we can use rocket engines that have as their oxidizer pure oxygen and as their rocket fuel pure hydrogen, the moon is a literal gas station. But of course, we need infrastructure, we need robotic infrastructure, we need human resources up there to extract the water ice and then split it into pure hydrogen and pure oxygen. And this is why there's a lot of good business opportunities creating infrastructure, communication, power grid on the moon right now, because yes, NASA have said as their goal to put boots on the moon, to have 2 humans, 1 female, 1 male, on the moon, and this is kind of a side quest from the main mission of Artemis, which is to help private companies put together infrastructure, power grids, have lunar robotics vehicles that can go around, do reconnaissance, and find good lava caves. So when young entrepreneurs in Norway come to me and say that, oh, Halvor, can you give me some alpha? What's the market like? I want to go into the space sector. I want to work with it. I always say, go to the moon. See what's needed on the moon. I mean, communication, internet for robotics. And yeah, I'm super bullish on the moon. I really don't want Artemis to kind of be sidelined by this Mars stuff, and I think NASA. They have worked through so many administrations and so much turmoil and wars. So I'm quite bullish in their steadfastness to continue building on the moon. I don't know, any comments?
Well, let's hope for it. I'm definitely on the same page as you are, because Moon is the natural next thing to go to. It's not Mars, as I said. But also with the administration, NASA administration, we will see. I mean, they also get a new head, who is very much aligned with the new administration and Elon Musk. So let's see what that really brings at the end. But I agree. I mean, the moon is definitely something we should explore further. But we should not forget about low Earth orbit as well. There's huge potential in there as well, in terms of commercialization.
Yeah, and in low Earth orbit, I think we will basically see a winding down of government satellites and have a purely private-made satellite fleet, actually. I also been working in low Earth orbit. There's little space debris to pick up in the deep space, but this is one of my favorite subjects. And talking about low Earth orbit. There is a big actor, obviously, Starlink, but we also have the Kuiper project and several other actors. I mean, you can just look around on Earth, and half of your POV will be the sky. And this slim line of the horizon, this is where we can receive internet information and, I mean, signals for anything else. So having internet in the sky, it's a great invention for humanity. Also, mostly for developing countries, actually. Matthias, what do you think the future of this mega constellation kind of ecosystem will look like? We saw from the Starlink Generation 1 being more than 1 metric ton to Generation 2, which is around 200 kilos. So we saw actually some miniaturization. What do you think will happen when we move a couple of years in the future?
Well, I mean, if I may, let's put this all a little bit in context. I mean, first of all, just looking in the audience, I wonder how many are really from the space business, how many are not. Maybe you can raise your hand saying who's space and who's non-space. So the majority is non-space, I would say, right? And I usually tend to ask in keynotes or panels with an audience like that, who has relation with space? And all the non-space people usually don't show up, right? And the same time, I'm asking who has got a smartphone, and of course, everybody's pointing up. And I think this is it starts with this. We all need to make ourselves aware that space is already in our daily lives, everywhere, anytime. I mean, your smartphone won't work. You couldn't navigate, you couldn't get the weather forecast, you couldn't do your financial transaction, you couldn't communicate, right? I mean, it's all backed by space infrastructure. And this is so important to always keep in mind. And it's not on an individual level. I mean, I would even say on an enterprise level, this is even more important. There is this example, and I'm slowly heading into the Starlink question. When the Ukraine war started, the first thing was that a communication satellite, a geostationary satellite, was hacked and cyber attacked. Well, the military expert knew then, now the invasion starts. But the collateral damage was that Germany couldn't reach like 5,000 wind turbines because they were also connected to this satellite. And imagine, I mean, Germany is building an energy transition on renewable energies, wind turbines among that, and they are under one satellite that can easily be switched off, and you can't control your wind turbines for 5,000 units for a few days. I mean, this is not impossible. And I don't know how many of the energy suppliers were really aware of the fact that this is a single source of failure there. So the awareness where space is in the non-space world needs to be much more elaborated, because we are building more and more infrastructure up there, be it communication, be it Earth observation. Navigation still is a pure government game, but let's see when we will have maybe private navigation constellations as well. So yes, the trend is definitely going into the mega constellation world, and that was my first company, also doing a satellite communication constellation. The fun fact is we were 10 days ahead of Elon Musk in making the regulatory filings for the operation of it. Unfortunately, we are Europeans and had very difficult times to raise the necessary funds. So we are a bit delayed, but still around and working on it. And we need to be very careful that we don't leave this critical infrastructure in the hands of single individuals. And they don't want to call the name again, but suddenly things change completely. And we have a critical infrastructure controlled by individuals, which is so critical also for government applications. And we need to find ways how we are managing this. I think the European approach would be probably a bit different than the approach of billionaires or autocrats. And we need to be very careful that there is a great balance somehow. And at the end, when investors ask me about all this, for the biggest risk I do see, and then we are coming to your topic, right? I mean, this is more and more satellites are creating more and more debris. And we have to be very careful that we are not kind of doing things we wouldn't do on planet Earth any longer, like throwing old refrigerators or car into the rivers, because it's environmental not a good idea. So let's not do this in space. And we are actually kind of doing this still, because it's still the Wild West. I mean, we are working on regulatory regime from the 1960s, slowly and a little bit updated, and it's not matching at all the situation we're having there. And we should not leave this to individuals to really drive this. It needs to be done more smartly.
Yeah, I agree, and we need some level of government intervention on this part. It's like the tragedy of the commons, like the oceans and the air. When everybody owns it, nobody owns it, right? Your own garden in your own house, it's easy to know whose job it is to maintain and keep nice flowers and a nice garden, because it's your property. But in the commons, like in the air, on sea, and in space, nobody owns it. Or everybody owns it, but nobody has the direct responsibility. And for low Earth orbit assets, these are traveling 27,000 kilometers an hour around the Earth. And this is what makes space debris actually dangerous for a possible cascading effect. This is called the Kessler syndrome, where you reach a critical point where you have so many individual objects orbiting the Earth that the probability of new collisions coming becomes so high that this will just become a runaway cascading effect, to the point where, I don't know if everybody here have seen the movie Wall-E. Yeah, Wall-E, it's my favorite movie. It's such a great film, and there you can see kind of dystopian view on human future where everybody is overweight and they just have turned Earth into a big pile of trash. And when they have this Exodus mission and they travel out of Earth orbit, they funnily travel kind of through this big fog of satellites. I can tell you this is not how it will look, because the satellites they will travel hypersonically. So the dangers of cascading space debris and the Kessler syndrome is actually that the Earth will just have this grid and fog surrounding it with billions and billions of pieces, which will destroy every single Earth observation, communication, broadband, internet, satellites, and actually trap humanity on Earth for 500 to 1,000 years. But luckily, this will not happen, because we humans have learned to pick up our trash and take a bit of responsibility. And I mean, what goes up will come down. Everything we send into low Earth orbit will eventually deorbit by themselves. It's just a question of when. And 2 years ago, the United States government came out with a list of the top 50 most critical objects in low Earth orbit right now, which it's basically only Cold War era legacy governmental satellites from the Soviet and US government. But these are these 50 objects. They have a median weight of 9.5 metric tons. So and they're big as trucks, as they could fill this whole room, some of them. And these are the #1 mission for everyone working in the space debris mitigation sector to remove and actually deorbit out of low Earth orbit.
I mean, as long as the pieces are that big, I mean, there are ways to grab them and then take them down. I think I'm more concerned about these little pieces, 1 centimeter or so, because they're traveling at the same speed, and they have a high energy level, of course. And if they're hitting a space infrastructure, this is causing damage. And to collect these little pieces is much more challenge. I mean, as long as a satellite or a structure is still intact, you can grab it and take it down. But these little things, I'm always dreaming of a vacuum cleaner, but unfortunately vacuum doesn't work in vacuum, so we have to find something else, right? But if you could just suck in these little things, that would be great.
Yeah, I agree. These bigger objects, they are so manageable, and I mean, 1 big object can turn into 10 smaller objects, which can turn into 100 and 1,000,000 objects. But these are definitely more manageable. It's the small pieces of debris that are actually the most frightening. And we have seen some examples, even recently, of solar panels being damaged, smaller satellites being damaged. And when researching at university, we visited at some point the Finnish Alvar Aalto University and the very talented Pekka Janhunen. This is the guy who invented electrodynamic tethers for the private industry and electrodynamic space sails. Super talented guy, and he helped us calculate actually the probability of an electrodynamic tether being snapped by just a micrometeorite, which acts pretty similarly in low Earth orbit to these small specks of space debris, and it was actually almost 1% collision chance per orbit, and objects orbit many times per day. So these are extreme numbers actually. But yes, I mean, when the regulation came in this October of 2024 to actually amend every single space mission to be deorbited 5 years after end of mission, I was very happy, and everyone working in the Sustainable Space Council, we celebrated really great that day, and it was a great day for humanity and for sustainability in space. And yeah, like we said earlier, private companies are pretty bad at picking up their own debris and their own trash, actually. So here, like long-term deep space missions, we need kind of a stable actor with tax funds who can just set the standard, and either if this is in kind of a fund where every mission pays a percentage of their total cost into a fund, which then can go to fund missions removing said satellites after end of mission, we will have to see, actually.
And I think this is even more important when we see more humans also working in a low Earth orbit, because so far we are just talking about mega constellation satellites that are very critical already today and will become even more critical. But we will see more space stations with people working there. And you might ask why, but microgravity offers great opportunities to produce better products, be it from biopharma, electronics, semiconductors, because of zero gravity. So we will see, and then this is all being prepared now, space stations where humans will live and work, but we will also see fully automated space stations. And we also should not underestimate the game-changing aspect of Starship, the big, heavy, the big fucking rocket
BFR
from SpaceX, which can transport like 100 tons and dimensions of like 36 meters by 9 meters. These are dimensions where you can really put industrial infrastructures up into microgravity, and we will see this happening the next 5 to 10 years. And I was so surprised because I'm also a big believer in big numbers in the low Earth orbit and lunar economy and how many people might live and work there. But I attended a conference end of last year in Lisboa on the space economy, and someone from the beverage and convenience food industry shared their view on how many people live and work in space by 2040. And even I was very much surprised. And they are assuming like 1 million people by 2040. This is 15 years from now. Whether we believe it or not, I mean, even if it would be 10%, we would talk about 100,000 people. I mean, we want to protect them. We don't want to kill them by space debris, right? And with all the other challenges like supplying them with food and drinks and, you know, with everything they need for their daily lives, not talking about what they need to get their work done. This is a whole industry that's going to be set up in low Earth orbit.
And for the Moon and also for Mars, the end game and the end goal is obviously to have a self-sustaining civilization and to actually be able to grow food, extract H2O, and the water from the soil. So, going back to low Earth orbit and private space stations, how will I mean, we've seen some early work on this for almost 10 years now. What do you think the kind of first private space station will look like?
Well, there are a few companies around, right? I mean, there's one company, Axiom Space in the US, that is building a station that docks first to ISS, the existing International Space Station, which I think is a very smart move because you are at the beginning using still the shared infrastructure of the International Space Station, build your own station, and then decouple when ISS comes to end of life by the end of the decade. They just recently accelerated the program because of the International Space Station also, you know, having Russians on board and with the Western world, with the other partners, it's a kind of a tricky situation these days. So this is one of the probably very promising approaches. But we also see other companies like Starlab or Vast. They are doing free flyers from the get-go, and this offers the advantage that you already can go into other dimensions. I mean, Axiom very much is still focused on the typical ISS kind of dimensions of the modules, also the way they want to ship it, because they would still use the Falcon 9 Heavy, while the other bet on Starship and can actually bring other space stations up. And the fun fact is, again here, with this sheer size of Starship and the weight they can transport, space stations of the future will be maybe built on shipyards. Because you don't have to build them like lightweight and very, let's say, fragile structures. You can just weld steel, because 100 tons is a lot which you could bring up, which offers, again, new opportunities for established industries on Earth to become part of the space race. but it will also show what is possible in terms of dimensions, in terms of weight. And by the way, a steel structure would be much better protected against space debris, at least the small pieces, than the very fragile other structures we have today.
Yeah. We had a great kind of old space and new space actor, Bigelow Aerospace. They did some pioneering work on inflatable space stations and inflatable space station infrastructure. Unfortunately, they went bankrupt 1 year ago, and but I'm sure we will see someone kind of taking over that part of the technological landscape in space stations. So we have a pretty good kind of outlook on what we're doing in America and in Europe and in the rest of the world. But China has a space station, actually, the Tiangong space station. It's operating right now, and as far as I know, there are actually taikonauts on board right now. And this is something that scares many people in both space defense and in governmental space agencies, because we know so little of it. We can see footage that they broadcast down to Earth. We can see that they have a fully functioning, highly technological space station. The ISS is obviously becoming older and older. It was planned for decommission actually already now, but will be extended to 2030. What do you think the Chinese kind of long-term goal is in space?
I don't know either. I don't have the crystal ball, but let's assume that's very ambitious, right? I mean, why shouldn't they? I mean, they have ambitions on planet Earth. So I guess every lead nation in the world has to be in space and will do significant things there. I mean, that's why President Trump also mentioned that in his inauguration speech. And again, coming from Europe, that's very important for us. I mean, this is a wake-up call to also be clearly committed to what's going on in space for all the reasons. And I think what we also should not be naive about is, and I didn't join the panel for space defense because I was committed on another thing, but both topics go so much together. I mean, if we have critical infrastructure, even if it's private, commercial, it is a critical infrastructure. And there are already capabilities today to destroy these infrastructures. So we will see even space warfare at some point. And we should not be naive. Of course, human beings will do the same things as they do on Earth, right? I mean, so we also need to think about how to protect our assets, how to defend ourselves, and how to make sure that we have international standards that are not only written on paper, but which also can be enforced. But just looking at how difficult it is, let's say, for the United Nations today on Earth to enforce things, one even don't want to think about how this will be in outer space, right? So a lot of challenges coming around, and all lead nations who are present in space, be it in low Earth orbit, on the moon, or outer space, deep space, this is with the ambition of course, innovation, research and development, commercialization, but also national interests, I would say.
And on the topic of commercialization, we spoke a bit earlier about the kind of private capital ecosystem in Europe contra the United States. How would you describe the kind of space investment side in Europe right now and compared to the United States?
Well, that's very tricky. And for me, it starts with a government making space a top priority. I mean, that's just words, right? Words you are really committed to, but this makes a big difference, and not see space as a nice thing to have. So governments need to be very much aware of the strategic relevance. It starts with that. Second, I'm not a big fan of grants and public funding in the sense of just pushing technologies. I'm a bigger fan of governments being involved as anchor customers. And again, here we should not forget that the US and SpaceX only could be that successful because of the DoD government contract SpaceX had in the early days and still has, which then allows also private capital to come, because suddenly your company becomes investable. So the government as anchor customer is very critical, and the advantage for governments is you're only paying if you receive a product or a service, right? You're not fund something without knowing what will be the outcome, but when you get a product or a service delivered, which is great in a way. When we talk about private money, I mean, of course, the levels in the US are totally different from what we're doing in Europe. We have some nice examples, yes, but we need more, because we are basically in all areas that are of relevance and have a great variety of startups and young companies. And for example, my own focus when I'm investing is indeed very much on Europe, because I think we need to collect these companies and build a strong base here as well. It's about sovereignty. We want to be a player here as well. But we are struggling every day in fundraising. And nowadays, even funds come and say, yeah, you know, we would do the next round with you, maybe up to Series A, but we have no idea who is supporting you in Series B if you're not going abroad. So we are not even doing Series A or pre-seed or seed because we have no vision. So you, as a startup, have to work very early on internationally, but then the temptation is pretty big that you are leaving your country too soon, and in particular when a lot of money is involved. Even more, a challenge we have seen the last years, it's getting better slowly, is the fact that still a lot of funds don't like dual use, not even talking about defense tech, which I only question because what is more ESG from a Western perspective to protect democratic values than doing it, right? I mean, why is space, why is dual use something which you put into the very dirty corners of where you don't want to make investments, right? I didn't really get this. Again, it's getting better and better, but this is really important. And at the same time, and this is where I work very hard with my portfolio companies, is make sure you get customers very early on. And there's one great example. I'm invested in a company that is building space planes, so horizontally taking off and landing space planes. It's, let's say, the future for me compared to rocket, which launch vertically and bring things up to space but not down. And they have subscale demonstrators, and subscale demonstrators could be drones. And this is already a product you can implement into the market and create customer traction. And a startup learns very early on that there is a customer to serve. I mean, the first generation of space tech startups, they were very tech-driven. They needed hundreds of millions to develop their tech and build their infrastructure before even doing anything with it. And I think that's not the way to go. So we need more healthy companies in that regard. So there are quite a few challenges, but if you master them, you will be able to build something. But yes, we have to be bold enough also in Europe to go big.
I totally agree. We need to be bold in Europe in a similar sense that the Americans are, and I also highly agree on the point of having government grants. This is such a perverted way of turning space industry and the real good commercial companies into some basically a paper machine that just creates papers and documentation for how our rocket engine is ESG friendly. I mean, and in Norway the public sector is extremely dominating to the point where since our inception we have been asked when we will move to Texas, basically. But we have steered away from these government grants and just to not dilute our mission and have our super talented rocket engineers sit on a computer and fill out forms on how our tech is ESG compatible, actually. So I always tell people when they ask me about this also, steer away. It's a trap. It's a honey trap. It seems lucrative, and this is also even for some kind of trans-governmental agencies in the space sector. It's also yields for them. It's a waste of time. This is just my personal opinion. It delays and it turns your brain from solving real problems with the technology you're developing to solving the problem of writing a ESG report which is not the rocket engineer's job at all. So yeah, I agree about this. And we are seeing, like, turning over again to the kind of private investment side of the European markets, we are seeing more and more great companies. In Norway, the Andøya spaceport is the first launch pad is actually completed, and we're seeing a couple of more being built. And you said earlier it's about sovereignty. And up until now, the only spaceport in Europe, or the only European spaceport, have been in French Guiana. So we have shipped rockets, every single Ariane rocket, to South America from Europe to launch it. And this is for reasons that you need a big body of water. You can't launch stuff from Davos because it's cities all around, and if you have a mission failure, you risk actually rocket parts landing down on and potentially hurting humans on the ground. We see countries that have a kind of a liberal a liberal way of doing this. The Chinese, they obviously launch rockets on a very frequent scale, and they give zero fucks about rocket parts landing down on villages. But having a European spaceport in Europe is important for this very reason, sovereignty. And for me, as a Norwegian citizen, I would obviously want there to be Norwegian-made rockets on our spaceport. But luckily, we have super talented firms in mostly in Germany, actually. 2 big firms in Germany that are creating rockets, and they are very, very talented. And they have kind of, at least for one of them, taken this kind of Silicon Valley approach where they have some of the employees in the US, they have an entity there, they raise capital from big known venture actors, and they go fast. The guy who taught me rocket science, he told me early on that he said, Halvor, you know, there's 2 ways to build rockets. It's the French way and it's the American way. And the French way is you work theoretically over years and years, and you plan out your concept and you do simulations on the computer, and then when you've worked for 10, 15, maybe 20 years, you make the rocket and you test it. And maybe it works and maybe it don't. And so very, very careful, considerate, slow development process. The American way is you create an MVP. You create 10 different rockets and you max out every single stat on them till some of them explode, and you just turn it to max capacity and you see, okay, this one didn't work, that one worked, let's continually build on this. And yes, this results in more explosions, but also more innovation. And we chose the American way in our firm. So how do you see the differences culturally, how people run their companies in the United States contra the European companies you have in your portfolio, for example?
We also go for the American way, and it was not an explosion, right? It was a unexpected rapid disassembly, right? and we learned a lot. No, but I think if you don't fail, you probably didn't move aggressive enough to move boundaries. So I think this is something which also describes this American approach, and we as Europeans have to really learn, because we don't like that. Failure is not an option, and in particular if you're coming from the space industry, this is a big thing. And just, you know, on the recent Starship launch, it was so interesting to see the headlines. In particular, the German newspapers were like, again, a failure for Elon Musk's Starship. Well, the international press was much more positive, and they should be, because at the end, it will succeed, it will come, right? It's about learning fast. Fail fast, learn and adapt and get better. And this is, for example, again, in the spaceplane company, exactly what we are doing there with the subscale demonstrators. I mean, they started like little devices. Now they're getting bigger and bigger. You're moving boundaries every time. You have your next generation of prototype. And then it's not this zero or one thing, then you're moving boundaries every time. You're learning, you're improving, you're getting better and better, and a better and reliable system at the end. But it's not in the DNA of us Europeans, so we have to learn that. But we have to learn, otherwise we won't survive.
Yeah, I agree. We need to adopt this kind of more cowboy mentality, actually, but in a European way. But yes, we need to kind of steer away from the classical French way of doing rocket engineering, I think, and this goes for every single vector in the space industry. So, guys, if you have any questions, feel free to just raise your hand, and we'll answer as good as we can. Are there anyone? Sir?
97, Alexander Dugin was a Russian. Maybe they say that he's one of the most important advisors of Putin. He wrote a book about geopolitics, and space is the outmost geopolitical battlefield right now. I work in a climate tech, and we are looking for space solutions for monitoring climate change, biodiversity assets. So I want to hear a little bit more on the defense side, but on a strategic, because most of the geopolitical powers today, they were consolidated through mapping the most strategical geographical places on Earth. But now we are talking about space, which is a general ground, let's say that. So who steps there first and settle their technology is going to rule the world. So it's not just, okay, let's join the hands and build something in common. Like you said, human beings, they are predictable because of its nature, and sometimes they can be quite dangerous. So how do you see this geopolitical aspect?
No, I mean, you're absolutely right. And I don't know this author, but I know Tim Marshall, for example, who published quite a few books on geopolitics. And I think in book number 4, space at least got a chapter. Book number 5 was entirely dedicated to geopolitics and space. Tim Marshall. And so you are absolutely right. And the challenge is you don't have any boundaries, frontiers in space, right? I mean, you have no borders. Even if some people challenge integrity of borders on planet Earth, I mean, if you don't have borders, how do you want to, protect them? How do you want to challenge them? And yes, we do see exactly what you're calling the Wild West, right? I mean, who is there first takes the stake, takes the claim, right? And it's getting more and more difficult for others. So yes, it is a geopolitical game, even more. But was your question only to the geopolitical side, or also to your startup and the climate thing? Absolutely. I mean, this is one of the very first applications of space-based infrastructures, Earth observation, to monitor and manage climate change, and all the different examples, right? I mean, it starts with weather, it starts with drought, it starts with flooding, it starts with wildfires. Basically, you can control everything at a very high revisit rate thanks to the mega constellations we're also seeing now in the Earth observation field. And now even with AI on top of it, you get really a great database and quite an intelligent system in order to do that. And I think that's also a very important argument always for doing space, because not for the sake of space, but space is supporting all 17 Sustainable Development Goals.
Yeah, last question.
Yeah, thank you, Halvor and Matthias, for this nice presentation. And 25 years ago, the European Space Agency seemed to be a competitor of NASA, of the Americans, in rockets. Now, it seems like it's about Russia and the US, and Europe is lagging behind, as you were saying, and all these developments of collaboration between private and public in the US looks like it really is making a difference. And how optimistic are, and you are very brave on having this private initiative, okay, but how optimistic are you that the Europeans are going to react and to be really a serious player in the next 20 years? Do we have the country's administration really sensitive to this matter to make this a reality, or how optimistic are you really?
Well, I'm an optimist. Otherwise, I couldn't work as an entrepreneur and investor. But I'm a realistic optimist, and sometimes I'm asking myself if I need to send the optimist in me on vacation, and the realist in me has to be the more dominating part for a while. And yeah, I agree. I mean, what was going on? I think NASA at some point decided very clearly we are no longer interested in everything that happens between Earth and Moon. We only are starting at Moon again because of the obvious reasons we discussed as a springboard for going into deep space. We only help private companies in commercializing low Earth orbit and lunar. That was a clear mission of NASA. ESA, with very limited budgets, still tried to play everywhere. So there was not enough money for anything to be very strong in. And this ultimately led into what the ESA chief, Josef Aschbacher, said is the European launcher crisis. And even today, Ariane 6, far too late, far too expensive, not really operational at this point still. We don't have it. And even the micro launcher companies, they are not launching yet. We need to get there at some point. But the question is, do we actually still have an opportunity on the launcher side to become competitive? If it's about government orders, it might work because there's sometimes national security interests why you want to launch with a sovereign launcher. And then price doesn't really play the role. But all commercial missions, I mean, SpaceX will take them all because they go in with every price. They are very competitive on everything. Again, that's why I was optimistically investing in a spaceplane company, because you are going to the next technical S-curve. I think the launcher, the vertical launcher game is over for Europe. We might see some niche players that might be even commercially successful, but this is not the dominating part. So with that being said, we need to be very ambitious on not just copying SpaceX and being 20 years late. We need to be very ambitious on what's beyond micro launches and satellite constellations, and this is conquering low Earth orbit and going to the moon. Yes, we have to be very focused on what we're doing. And I think the next 4 years are very decisive, because the US now, with the new administration, will really push very hard. They will do everything and they will move boundaries. And Europe has 4 years left. And as you can imagine, I am observing that very closely.
You are very brave. Good luck. Congratulations.
Thank you. I need your help. I mean, help me.
Yes, kudos. I agree. The future belongs to the optimists. And with that, we will actually end our session here. I would like to thank Matthias a lot. Thank you for joining this, and thank you guys for coming. I will be here the rest of the day. I'm available to answer any question and have a talk. And thank you so much.